Hey, Lady Ada, what is this?
Hello, everybody, and welcome to Show and Tell. It's our weekly hangout we do every Wednesday at 7:30 p.m. Me, Lady Ada the engineer, with me, Mr. Lady Ada, here in the Adafruit factory in downtown Manhattan, where we make all the electronics and do the tutorials and guides and firmware and code and all the things that you know and love about Adafruit. It all happens here. And right now, we're going to invite y'all into our virtual home. People from around the world. Some of them work for Adafruit, some of them don't. And maybe they can show off some of the stuff that they're working on. We're going to be here till 7:50. So when we call on you, unmute your mic. Show us your project for a couple minutes, and we'll get to everybody. Let's start off with Noah and Pedro.
Hey, what's up, everybody? So let's take a look at our overhead. So this week's project has to do with Circuit Playground Express, our favorite board here. And what we got inspired by Sophie Wong's sort of con badge. And I kind of wanted to make my own, but with like a PCB. So we milled a couple PCBs using our Bantam Tools desktop CNC. So this is FR1 board, and it's basically just a little add-on that breaks out some of the capacitive touch pins on the Circuit Playground Express. So we have 7 of them here, and this is an example of sort of milling away everything but the traces. Which takes a little bit longer. So this one was sort of the second version. The first version was just kind of the fastest way you could mill, which is just kind of doing the outline of the trace. It leaves a lot of the surface area, and this is kind of what happens when your copper is bare and isn't protected. But you could, of course, do some solder mask, which we did a tutorial on how to use UV curable solder mask. So that's the pretty simple design. We put it together in Eagle CAD, which is from Autodesk, and we used Lamar. Your design, of course, was done in Eagle, so we kind of tore it apart and made a little library. So if folks want an exact placement of these little pads here, you can use our little Eagle CAD library. So we put together this little synthesizer using MakeCode. So you can go to makecode.adafruit.com, and what it does is it just makes notes. So you kind of have your basic notes. And then we also wanted to do some arpeggios, so you can kind of group notes together to make kind of these funky sounds. Let's see if we can move our microphone down a little bit so you can hear a little bit more. Let's see. How's that? There we go. And we talked about it on our live show, which we did in the morning, and we kind of showed how you can create up and down states to create these kind of effects, these behaviors. And that's pretty much what the project does. And of course, since it's using Circuit Playground Express, you can do a lot of different things. Maybe shake it, use the accelerometer to trigger different things, and port to different animations as well with neopixels.
Neat.
And that's kind of it. So if you guys want to check it out, it's on the Learning System, and we also have a video on the YouTubes. And all the files, of course, are available, open sourced.
And we'll be playing those on the show. And program announcement, you're going to be around next week?
Yeah, that's right. We'll have a special 4th of July edition somehow.
Firework edition.
Yeah. In here.
Awesome.
Okay.
Thanks so much, Pedro.
Thanks so much, Pedro.
What's up, Phil B?
Phil B.
There's my mic. Good?
Yep.
Good. Okay, it is Pixel Day. I got a couple things to show. I did show this a couple weeks ago. It's the boy, that's awful bright. Well, can't help it. The LED matrix library that we have, I had adapted it to work on the Metro M0 and M4. So we got the new shield. It makes it real easy to plug that in now. And I like promised it a couple weeks ago, and I didn't get it put in the repo until last night, I think. But code's there now, and these things they really benefit from the ARM chips. It was just asking a lot for an Uno to do. There's just no RAM there, So should be able to do some pretty cool blinky projects now. There's actually it's just blown out, but there's actually a whole color wheel there. It's really nice in person.
Sometimes if you put it really close, that makes it like the camera.
Yeah, you can kind of see there. There's some color going on, but yeah, it's a nice RGB color wheel that just totally blows out on the camera.
Maybe try the sheet of paper if you have one.
Not handy. I'd have to take it in the house. But anyway, the other thing, speaking of M4 stuff, is we have been working on talking very quickly with these TFT displays.
Yeah, that's nice.
And that's one of the 320 by 240 displays being driven by an M4, and that's basically the same graphics as the old Amiga Boeing demo, running on the M4 now. And this was one of those kind of perspective moments. It's like, yeah, I know the M4 is fast or whatever, but you don't really think about how fast until you realize that that took like everything we had back in the day.
Yeah.
That was like it. Like you couldn't do anything else.
Yeah.
Exactly. And this is like really messy, like not even well written code. And it's able to. It's funny. It's writing the screen at about 180 frames a second, which is actually faster than the TFT even refreshes.
And welcome to Show and Tell. So
Someone has a video on the background.
Yep. But it is insanely fast, and we're working on a library for doing gaming type stuff with the M4 on one of these screens, and that was kind of like the hello world. Okay, I think we got it moment right there.
But Phil B, are you like banging all of those pixels by hand? Or you're in you have a for loop and you're just like writing all the pixels by hand, right?
That's a good question. Thank you. No, we are using DMA on the M4 and the parallel. I forget what it's called, 8080 parallel mode or whatever of the TFT. So there's eight lines of data going to the display, and it's all. SPI is doing the data, and then there's this whole wacky thing using the event system on the chip to generate the right pulses, like automatically at the right time. So
it works great.
Yeah, it was hard getting there. There was a lot of times along the way. It's like, well, this isn't going to work, and then you try another thing and another thing, and it eventually works out. And
that's how hardware is, right? Hardware doesn't work until it works, and software works until it doesn't.
Yeah, that pretty much. Yep. Right. But anyway, the logic analyzer was just so helpful in diagnosing, troubleshooting that.
All right. Well, that's coming soon. So people who are excited about DMA TFT at 180 frames per second can look forward to that next coming week or two.
Okay. Next up, JP.
Hey guys, so I'm gonna go so much lower tech and hands-on paper goods style here with my project. I love that project that Phil did. That is amazing to me. So this is the little Minerva Papercraft Owlbot. I just released a guide to this yesterday. It came out on the Learn Guide system, and so let me start off with some of the genesis of this was. Mr. Lady Ada there had done a Bob robot, and he showed me this really cool technique of taking two cups and painting your eye sockets on the outer cup and your pupils and irises on the inner cup, and then you move the inner cup and you get this really great little glancing motion. So I decided to use that method for this Minerva bot. So it's a cup inside of a cup. And then I've also got a second, so there's a servo under the bottom that's moving that cup. And then I've got a second servo in the back, which pulls these wings. Every time this turns, it will pull these little wings and flap them. So I have a Cricket and a CircuitPython Express running these, and then a little speaker on there too, so that Minerva can say some lines. So let me just flip that on for you. You can see her in action. So I have that very, very simple right now. It's able to play a WAV file, and at the same time as it's playing a WAV file, it runs the eyes back and forth and the wings flap, and it actually does that as long as the line of dialogue is. So it's amazingly simple code. You can see the CircuitPython code that Lamore wrote, this little loop, and we've used it in a few of our little robot demos. Makes it just shockingly easy to do this type of little looping audio animatronic. And then, of course, you could get much more complicated where it's interactive, using light sensors, doing different animations with different bits of dialogue, and so on. But I think this is a really fun leaping off point for people who want to try out Cricket and try out some robotics in a really cute little character form. So that is our Minerva Owlbot. And
Excellent.
I will be doing a mini golf based project on my live stream tomorrow. So tune in at 4 o'clock Eastern time to see what my mini golf hazard is going to be.
Okay. Next up, Sam. Hey, Sam.
Hello.
Show us what you got.
Thank you for having me. So, my friends and I like to play a lot of board games, and we like a particular board game called Robo Rally, where you navigate little robots across the game board. And while that's fun with little plastic pieces, we think it'd be much more fun with actual robots. So we spent a little time building these little robots here that you can see. I apologize for the quality. This is my first prototype, which was handmade.
This is fine.
And then later, we actually developed a PCB, so you can assemble them much faster and much more easily.
Oh, that's nice.
Yeah.
Yeah. So this is based on a TeamCLC. I use a lot of the magnetometers and gyroscopes from Adafruit to navigate around a 5-foot square game board using magnetic tape. So instead of doing optical line following, we actually do magnetic line following. So we can put our game board on top of that and not have any lines crisscrossing the game art.
Good idea.
So I'm going to show you quickly the player interface, and I'm going to try to show you the board. You have to forgive me. My Brooklyn apartment's a little small for the game board, but I can give it a shot.
Yeah, we have an apartment in Manhattan, so that's why we...
Dude, Brooklyn's a tough place to do a 5x5 board game. Like,
that's why when we do Desk of Lady Ada, the entire set is within a very small range.
Hi.
Yeah.
It's small.
The game server is running on a Raspberry Pi, running ASP.NET Core natively, so Microsoft's new open source .NET framework. And so you have a web interface here where you have a bunch of different cards that give instructions to your robot. Move forward, turn left, turn right, U-turns, and backups. You pick 5 of them for your program. I'm going to try to do this. And you slot them into your slot here, and then they'll execute those 5 cards in order. And every player does this, and they'll do everyone's player card 1 and then card 2, and so on. And then if you get pushed out of the way or bumped or moved, your robot will keep follow the pattern, but now it's on the wrong path. And so you have to kind of think ahead and try to anticipate what another person's going to do. So I'm going to try to move out of the way here and show you the game board itself, which I've set up kind of all over my floor.
That's great.
And so the robots are there in the front, and they're lit up and connected. I'm going to send one of mine off on the way. So there he goes. He goes forward 1.
Robot.
And then while it's pausing here, it's actually executing all the game board elements. So there are conveyor belt, which he is on now, which is going to move him down that conveyor belt. And that doesn't always work so well when they're driving. I think he actually ran over his cord, so that is not good. We're actually
part of the joy of robots.
We're actually working right now on a new implementation using a 3D printed chassis and hopefully li-poly batteries, so that it's not quite so janky. I think he just drove off.
Bye.
There he is. But yeah, so I've actually taken this around to a number of schools, Medgar Evers College here, a couple of Origins Game Fair, and of course Maker Fair, which we'll be at actually again this year. And we find that kids especially really respond to the game aspect of it, and they love to play with it, and they love to practice programming the robots and seeing it do what they tell it to. And then they want to try to build one. And I think it's a really great way to engage kids and, frankly, myself in these kinds of activities. And it's all open source. You have all the code and everything up on GitHub. We have fairly detailed instructions on how to build it on our website, roboruckus.com. And yeah, so that's just pretty much where it's at right now.
All right. Great work,
That's
Sam.
great.
Do not pass go. Do not collect $200. Email support@adafruit.com, and we'll send you an as seen on your show and tell sticker.
Oh, wonderful. Thank
Yeah.
you.
Nice work on your
I
robot.
was
Looks
trying to keep
great.
it board game theme.
Yeah.
All right. All right. Next, Wayne. Hello, Wayne. Show us your project.
Hey, hello, Adafruit. Can you hear me okay?
Yep.
Yes.
All right, great. So a newbie to the forum, but been watching for a while, and wanted to show off something I've been working on. Actually, this has been going on for a couple years, and it was featured on the blog a couple years ago. It is a drifting buoy, so an ocean-going buoy project.
Yep.
So this piece of hardware basically gets thrown out into the ocean and inside a case. And what's changed recently is that decided lots of inquiries, so decided to make kind of a open source version of it. So inside here you could see a kind of a 3D printed case. Sorry about that. So a 3D printed frame and a bunch of Adafruit components. It's a Feather M0, and since I've never done it, let me see if I can share. I can share this. that come out.
Mm-hmm.
Yep.
Yeah, so basically a Feather M0 and a bunch of other Adafruit components, including one of these new 1-watt panels. They're really nice. And GPS, and then what makes this all work is it's actually using an Iridium modem.
Yep, that's a great use for it.
From a company out in the UK. Again, what's kind of new though is that this is now up on GitHub as a open source project, and all you need is a bunch of parts to be able to 3D print, and then it goes in a kind of a standard case, kind of like a camping kind of case.
Yeah.
So it fits right into the center of it. You close it up, and you can throw it in the ocean and follow it with your on the web.
That's so cool.
That's great. Well, the only thing it's missing is as seen on show and tell. So before you toss the next one, put a sticker in there. And
They're vinyl stickers, so they should last even.
Well, they put on the inside.
Yeah, but it won't get UV weathered, so that'd be great.
Right.
Floating in the
Actually, if you go to well, you can look up Maker Buoy. Also, if you just go on Arduino Drifting Buoy, you can find the site, and the original one we put in that was on your blog. That's just past 700 days out in the Atlantic.
Wow.
Oh, wow.
You know, for what it's worth, these components just work. You know,
It's like Mars rover time. Like
I know.
it's
700 days is quite a lot.
Thought it was gonna last a week, but it's still out there.
Yeah. So I got to continue to pay for it, though. That's the problem.
Yeah. No. The Iridium.
The Iridium bills are expensive.
Yeah. All right. Thanks so much, man.
All right. Yep.
All right. Next up, Jason. Hey, Jason.
Hello. We can't hear you. We can see you. Nope.
Yeah.
Nope.
There we go.
Hey.
Fantastic. I'm totally new to this.
That's fine.
Us
I'm
too.
new to this too. I've never done this before.
Yeah.
Oh, never. So I spent like 5 minutes. Oh,
Yeah, you're good.
What's up?
I still could hear the other stream. So I have a little digital badge.
Okay.
It's
cool.
It's built on a custom PCB using an Atmega 328, and it has. Let me turn it on here. Turn on. There we go. Can you? Looks like it's okay.
Oh, it's like a dragon or something, or a phoenix.
It's a phoenix. I have a company named Phoenix Born Technologies. That's its logo.
Okay.
Yeah.
But it has. I'm trying to do this and keep it visible. Has a menu system. Give up. All right.
It's all good.
So it can do. This is its primary use. Is the color badges for. It's for conventions for how social people want to be. Green, you want people to come talk to you. Red, you want people to leave you alone. And yellow for basically friends only.
Yeah.
That's a good idea.
That's a good idea.
Because it's Arduino, I kind of went a little bit overboard. I put pride flags on it.
Oh, yeah.
Those are the badges and pride flags are both programmatically done, but it also has a micro SD slot, so it can load the 28-bit images in both a still image and slideshow mode. There's the Phoenix, and these are some of the art that I've had done by my friends.
Cute.
Obviously, it's in slideshow mode, so it's just kind of cycling through right now.
Yeah.
That's great.
It looks great.
It had like 4 bytes left in program memory for that Atmega 328. I want to do an updated version. Right now, this one's doing right off the batteries. I'm going to do an updated version with the boost converter, and I eventually want to put the SAMD21, maybe 51 on there so it can do CircuitPython, because everything's easier with CircuitPython.
Yeah.
You said it. And the other thing is it can show up as a USB drive so people can update it very easily.
They can just drag their images they want.
Yeah.
That's the idea we had. Like everyone's got like their icon or like avatar. They can drag that on and then they can display. And you don't need an SD card reader because everyone has a micro USB cable.
Yeah, I'd love to put the flash on there so they could just go, oh, hey, here's my image. Put it on there.
Okay,
all right,
sounds
Jason,
great.
This is an excellent project.
Nice
Email
work.
support at Adafruit. We'll send you an as seen on the show and tell sticker. And then for bonus points, if you could put the graphic on as show and tell, you can ask the team for it and they'll email me. You can put that on there too as in a digital.
Oh, that'd be amazing.
Digital sticker.
All right. Thanks so
Okay,
much.
Thank you, Jason. All right,
Okay.
your guitar.
Guitar. How's it
Welcome
going?
back. Get your armor.
Hey guys, good to be back.
Yep.
So I wanted to give an update to my Dark Samus cosplay that I came on, I think, like a month or two ago. Last time I had the chest piece and like the torso, so the addition is the helmet.
Right.
So before I do put it on, I wanted to just do a quick screen share of the reference picture just to kind of show everyone what it's supposed to look like.
Okay.
Yep.
Yeah.
So this is the reference picture of like the whole cosplay and the addition of the helmet. Okay, so here is the helmet. I 3D printed the helmet on my my Taz 6 in one shot.
Yep.
I put some LEDs in it.
Oh, that's
Ooh, that's awesome.
At a distance, the nice effect is at a distance, the lights kind of blur together, and you don't really see my eyes.
Yeah, it
So
diffuses
kinda
nicely, and your eyes they look dark, and so it just looks like there's like some screen or something going on inside there. It looks really good.
That's nice.
So,
All right,
Great work.
outstanding. Well, keep collecting the As Seen on the Show and Tell stickers. I know it won't match the photo, but you could still slap a sticker on that. And,
thanks.
all right, thanks so much.
All right,
and we're
thank
going to
you.
wrap up with Isaac.
Hey,
All right,
Isaac.
what you got going on?
So my guide to the compost tumbler is finally up, and thanks Mike B for helping me out with that one. After you build the tumbler itself, you're going to want to know when you actually want to turn the compost, because you don't want to do it every day. You still have to like actually physically move it. So I've been working on some prototyping a little bit of here's some sample compost here.
Mm-hmm.
Ways to know when it's ready to be turned.
Okay.
So there's two main reasons why it might need to be turned. And they deal with temperature and moisture. So all I need to do is get a temperature sensor, and I'm using the Circuit Playground to do the capacitive touch for the moisture. So right now I have some dry soil that the Circuit Playground is in, so you can't really tell, but it's red and yellow lighting. The yellow means that it's not hot enough, and the red means it's too dry. So I'm going to transfer over the alligator clips to the wet soil. Sorry,
Okay.
the wet compost that's a little bit warmer, and it should turn green. And so the idea is that based on the color of the Circuit Playground, so you can see it's green now.
Yay.
It's kind of going between, but
Mix your compost.
yeah. So based on the color of the Circuit Playground, you know what to add to the compost and then when to turn it. So
Great.
yeah, it'll be attached to a solar panel, and hopefully it'll just be a little rig that you can attach to the compost bin itself. So that is in the works.
All right, keep it
Awesome,
up.
nice work.
And good work on the guide.
Yep.
Thank you.
All right, well, that's the show and tell this week, everybody.
Thanks, everybody.
We're here every single week, 7:30 p.m. Eastern time. Keep showing and sharing your projects. Thank you, Wayne. Thank you, Sam.
Thank you, Phil. Thank you,
Pedro.
Noy. Thank you, Minerva. Thank you, Jason. Thank
And
you, Isaac.
We'll see everybody next week. Even though it's 4th of July, we'll be here.
We'll be here.
And we'll be...
Maybe you'll be able to hear the fireworks.
Yeah, and thanks for making this the best half an hour. And thank you, everyone, for showing it's possible to show and share your projects from around the world. We do this, and it only happens because people come here and show their projects. So thank you, thank you, thank you. All right.
Thanks, everybody.
Hi, everybody.
Boing, 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 boing. I love that demo. I gotta find the Mac version because I distinctly remember it, and it blew my mind. But it was
All
black and white. I don't know if anyone knows where to find the Mac version's demo.
Tweet it to Adafruit if you find it.
Tweet it to Adafruit. I couldn't find it on the Internet Archive.
Okay, bye-bye.
Bye, everybody.